So I really want to finish this this whole unit tonight, but I've just decided that I don't want to sit here and talk about these two questions for the next hour of my evening because I'm getting a little hungry. So what I'm going to do is I'm going to do it in two videos. I'm going to do a video taking care of question A, and then I'll do a second video using question B. So I am going to erase this right now and ignore its existence. And then I am going to come back and erase this one, assuming that I can, and no, I can't, so I'll just mark it out, and we'll do that second one in a second video. I know, based on my history of calculus, that I need more paper. So I'm going to assume 3. Oh no, I'm going to assume 4. So this is with me and the smartboard. It would take me one piece of paper minimum in my handwriting if I were trying to be super, super neat, which I'm often not. So with this question, here are the steps, and you can check your resource sheet if you like, and I will flip back there in a second, but these are the things that we have to pull off. We have to pull off, am I plugged in? I'm not plugged in. Hold on a second. Ah, there we go. We have to pull off finding intercepts. We have to find, is that my color combination? No, it's not. We have to find vertical asymptote plus test. We have to find horizontal asymptote plus tests. And of course, if neither one of these exist, we just don't do the test. Then we have to, and I can't remember my color coordination for this, and so I'm going to keep it with red. We have to find the max-min plus the first derivative test. And then finally, and this is all before the sketch, we have to find the points of inflection, and we're expected to do the second derivative test. Now, what makes these questions, rationals, far worse than any polynomials is not the existence of the horizontal and vertical asymptotes. It's the fact that we're going to have to use the quotient rule for this. So that stuff doesn't go away. So I am going to take both the first derivative and the second derivative now, because I'm going to use the first derivative here and I'm going to use the second derivative here, and then I can clone my page if I need to, or I can drag stuff around. So a reminder of the quotient rule. Derivative of the top, nice and easy, multiplied by the bottom, minus, for the quotient rule, the derivative of the bottom is 0 minus 2x, times the top, over the bottom squared. And if you didn't already know why you had to multiply this out and make it look pretty, now is why, because you're eventually going to have to take the second derivative. So 0 times anything is 0, so I'm not going to write that down. Negative negative makes a positive 2x in this case. All of that over 4 minus x squared all squared. And now I can take that and I can do the second derivative. So there's the original, there's the first derivative, now I'll do the second derivative. So you can see why I need all this paper. So the second derivative does not need the original, so I don't need it to be visible, but I need to do the quotient rule again. So I just rolled my eyes, you can't see that. So derivative of the top multiplied by the bottom, minus, because it's the quotient rule, the derivative of the bottom needs levels, so drop the 2, keep writing, make it 1 less, go inside, take the derivative of that, multiplied by the top. By the way, you decided to take calculus, not me. Over the bottom squared. So when I look at this, I see that there is a 4 minus x squared bracket before and minus the plus sign. So I'm going to take one of them out without cleaning it up. And there is at least a 2 in both before and after the plus sign. And I'm going to take out one of them, not two of them. See how bad typos can make things? So now, this is gone. One of these is gone, so I need one left. And I'm not going to put it in a bracket because there's nothing in front of it. Minus, the 2 is gone. This is gone. And I'm left with negative 4x squared. So negative 4x squared turns that into a positive. And then all of that over 4 minus x squared squared. Now it's all multiplying. So it's 2 multiplied by this round bracket, multiplied this by the squared bracket over this. So I can actually take out one of these with one of these. So this isn't so bad. At least it's cleaning up nicely. And my final version of the second derivative needs the 2, needs the 4 minus x squared in the denominator, and this will be 4 plus 3x squared. Yes. So there is my second derivative. So now I'm going to start up with x and y intercepts. So this is what you need for x and y intercepts. So 1 over 4 minus x squared. Y equals 1 over 4 minus x squared. So back to the old advanced functions drawing board. And this is why the labeling is so important. Tell me what you're finding, because there's a heck of a lot going on here. So let y equal 0. So that's 0 equals 1 over 4 minus x squared. I have a fraction on one side, so I'm going to put a fraction on the other, and then I'm going to cross multiply. So 1 equals 0. And I don't know about you, but 1 does not equal 0, so that means you have no x-intercepts. Y-intercept, let x equal 0. Showing as much or as little work as you want. And we're done. And at some point, I have to come back to this page to remind myself that I have no x-intercept and I have a y-intercept of 1 over 4. And because I'm going to have trouble finding this, creative pen, star my work. So some of you are monster gel pen users, some of you like highlighters, some of you like circles. I'm going to use the star. So I'm done that. But I feel like I've lengthened this page enough, so I'm going to do my vertical and horizontal asymptotes on the next page. Then I'm going to do my max-min on the third page. If I have room, I will find my point of inflection on the third page, if not the fourth, and then I'll put it all together on however many pages I need later. So I have actually been able to, no longer need the creative pen, I have been able to check off this one. I'm done that. So what I need now is I need the vertical asymptote. So I need the original again. So I'm going to take this, I'm going to clone it, and I'm going to pull it to my asymptote page. And let's get rid of this. And you can hopefully see why I don't want to do this all in one go. And vertical asymptotes, I chose blue. So vertical asymptote, you let the denominator equal 0. That's a difference of squares backwards. Not that there is a difference of squares forwards or backwards, but we get that. That means we have 2 minus x equals 0 and 2 plus x equals 0. With this one, you want to take the x across the equal sign to the right, and this one, we want to take the 2 across the equal sign to the right. So we end up with vertical asymptotes of x equals 2 and x equals negative 2. This is kind of the proper way of doing it. Now I'm going to do my tests. So test left, test right. I'm testing x equals 2 first. So limit as x approaches 2, limit as x approaches 2 from the left, from the right, of 1 over 4 minus x squared. 1 over 4 minus x squared. So I'm going to pick some values, and I'm going to let you know which ones I'm picking. So I'm going to pick to the left of 2, 1.9, and to the right of 2, I'm going to pick 2.1. And I think I can do this in my head without using the factored version. So if I put 1.9 in there, I can't. So it's positive, because it's a 1. And if I put 1.9 in here, that's 4 minus something that is less than 4, which is positive. So I end up with positive, which is up. Next one, 1 is positive, regardless of what I put in. 4 minus something that is bigger than 4, because this is bigger than 2, is a negative. So this one does alternate. And then I'm going to do another test, boo, for the right side and left side of -2. So still the same, oops, not what I meant to do. Still the same stuff to write down. -2 this time. -2 this time from the left side, from the right side. And 1 over 4 minus x squared. 1 over 4 minus x squared. So on the left of -2, I'm picking a number more negative, and on the right, I'm picking a number less negative. So if I put -2.1 in here, I can't. And if I put -2.1 in here, I'm going to get something bigger than 4. So 4 minus something bigger than 4 is negative. That is a negative, so that's down. And -1.9 in here is positive. -1.9 in here will give me less than 2. So less than 4. 4 minus something less than 4 is positive. So that's an up. So there's a lot of scribbling in calculus, which is why you don't always need a calculator for this course. I'm going to change colors and do horizontal asymptotes. Then I will take a little hand break. So horizontal asymptote, limit as x approaches positive, negative, infinity. Now you know that limits are part of calculus. And it's 1 over 4 minus x squared. So if I mentally divide everything by x squared, I will have 1 over x squared, I'll have 4 over x squared, and I'll have x squared over x squared, which is 1. And because of this statement, if you miss it, you can't do this, but because I wrote it down, these two make 0, and I end up with 0 over -1, so I end up with 0. And now I can do my test. So f at -10 minus horizontal asymptote, f at +10 minus horizontal asymptote. Now the nice thing here is, let's say you forgot to subtract off the horizontal asymptote. I would never know, because subtracting off 0 doesn't really do anything. I'm going to write it down anyhow. So that's 1 over 4 minus 100, which is negative, so that's below. And this is 1 over 4 minus 100, which is negative. So that's below. So right now, my choice is, because I've got so many stars kicking around already, and I haven't even started my derivative work. I'm going to be annoying to you, and I'm going to start my graph. Now remember, even though I'm doing it on page 3, it doesn't have to stay page 3. I have the ability to move it around. You could do it right now and then add on after the fact. I like to just get that much out of the way because I'm already a bit stressed out. And I believe that the bigger you make your picture, the better the picture is, because it's easier to read for both you and me. More importantly, you. Because you've got to follow your own work. So let's go back. I'm going to do asymptotes first because I like to place on my lines. So I need a 2 and a -2 that are vertical. With labels and rulers. I never have to look at this again. Up, down. Remember the logic between doing left on the left and right on the right. Down, up. Horizontal, y = 0. Which means it's right on the x-axis. So I'm going to put it just barely visible, definitely with a label. And again, I did left on the left and right on the right, but it really doesn't matter because below is pretty impossible for me to screw up, I would think. Now, some of you might look at this and go, oh, I already know what this picture looks like. And that is awesome, but we need more details. So, and I need to show you how they fit together. Because you are not doing this for me, you are doing this for whatever purpose you are taking this course for. I haven't even looked back this far. So remember that we did x and y intercepts, so I've got no x-intercept, so I'm not allowed to touch the x-axis ever, so it doesn't go through the horizontal asymptote this time. And I've got a y-intercept of +1/4. Remind me later. I hope that doesn't mean I'm going to crash things again. Y = 1/4. Label it. All right. So now I'm going to reach back in time and I'm going to steal this, which is the first derivative, so that I can go on and do max, min, and first derivative tests. It actually means I need to steal 2 things. I need to steal the first derivative. And because I'll need the points, I need to steal the original. So I'm going to shove that here. And nope, didn't grab it yet. Shove that here. So, the max min. Red. For no other reason than 'cause. Max min is where you take the derivative, which is the slope of the tangent, and you make it equal to 0, which in this case, I'll need a 0/1 to do that cross-multiplying business again. So this way gives me 1 times 2x. This way gives me 0 times I don't care. Divide both sides by 0. And I end up getting I just remembered I need a hand brake. I end up getting that. So then, have I done something wrong? I need to find my y. Sorry. I'm just looking at this going, oh, how did I get that? Oh my goodness. So let's keep going. Trust your math. Trust your math, tell us. So y is equal to, and sometimes I have little brain farts. Because I didn't just find the x-intercept, I found the y-intercept. So I already knew this point. In fact, it's already on the picture. Sometimes you get extra information, sometimes you don't. Now I have a first derivative test. So I need to tell you I'm going to do the first derivative test because there's a whole lot going on. And I need to refer back to the sheet because there's some new stuff you need to think about. Ready for this? So I told you previous to this that you have to put on the x value onto the number line. So you have a visual. Now let's go back to this sheet right here. Where'd it go? Resource sheet. If I take a look at the max-min section now that we've started rationals, and I can blow it up just a little bit. It says, max-min, take the derivative using the chain rule or product rule or quotient rule. Done that. We let the derivative equal 0. We solve for x. It's called a critical number. We haven't figured out if it's a max-min yet. And we've subbed the x back into y, so you get two numbers, an x value and a y value. And this, you could have none of them, you could have one of them, you could have more than one of them. There's multiple. You could have a max-min, or you could have a trig point. We don't know what this is yet. It depends on the first derivative test. Now here's the kicker with the first derivative test. Draw a number line. Done. Put all the x values from max-min on the number line. Not new. New. And the vertical asymptotes. So you have to put the vertical asymptotes on. So if you were previously excited about the fact that, oh, I just have to put a 0 on and I can test over here and I can test over here, no. Sorry about that. You have to reach back into your vertical asymptotes, whether it's here or whether it's on the picture, and you have to put on 2 and -2 onto your x number line as well. So you have other values to work around. And that's because you're not allowed to pick an x value of -2, and you're not allowed to pick an x value of 2, so now you have more values to test in between. And I am going to go back, and I am, oh, who let me do that? This was a single derivative. I'm going to go back and use this version for my test. So I'm going to clone it, stick it here so I have it visible, call it the right thing this time, don't do calculus when you're tired, and now find values in and around. So I am going to check x equals -3 in the first derivative. So that'll make this positive, this negative, -6 actually, and it'll make this bracket negative because it'll be 4 minus 9, but the bracket is being squared, so that's a positive, so we end up with a negative. And a negative means decreasing, which is worth putting on the number line, because we're going to reach back and not worry about anything except this, which we already knew. Sometimes we gain new information, and whatever the result is from the first derivative test. You're just going to look at the picture and what's going on. If it helps you, my suggestion is remind yourself that these were your vertical asymptotes. Horizontal asymptotes don't matter because horizontal asymptotes are y equals, vertical asymptotes are x equals. So let's move along and pick a number between -2 and 0. I just stole my own thunder. And sub it into the first derivative. So 2 times -1 is negative. -1 squared is 1. 4 minus 1 is 3. 3 squared is positive. And I end up decreasing. And this should not panic you. And it's also a reason why I put the vertical asymptote lines on there. Rulers are not necessary. Because you don't care if it alternates over a vertical asymptote. What we're caring about is this one. This is not the vertical asymptote. This was our value. So I am hoping that when I pick a number between 0 and 2, like 1, I'm hoping that I end up with an increase here, because then it'll make this either a max or a min. So if I put 1 in here, that's 2, which is positive. And if I put 1 in here, it doesn't matter what this bracket is. I'm going to square it, and it's going to become positive, which means this is positive, and I'm increasing, and I do actually have a max or a min. Once I'm done my test, I'll think about what that actually means. And don't forget to test out here. 2 times 3 is 6, which is positive. Don't care what this is, because when you square it, it's positive. And that means it's positive and it's increasing. And again, you don't care if it increases then decreases over a vertical asymptote. You only care over these critical points. So now I know that if this is decreasing, then increasing, this point right here is actually a minimum because it bottoms out. All right. I'm going to make a new page just so I don't make this so long that you can't read things. Oh, big yawn. I still have another question ahead of me. So I'm going to reach back to the first page, and I'm going to clone the end result of the second derivative, and I'm going to name this properly. And I'm going to reach back and clone this, because don't forget I'm going to need that to find my points, my y value of the point of inflection. So yay, labeled properly for both of those. And now I'm changing to blue because that's all I retained. And I'm letting the second derivative equal 0. And just like every other rational function, if a fraction is on one side, I should put a fraction on the other so I can cross multiply. So 1 times anything is itself. And 0 times anything is 0. So now I can dig out my green pen and say 2 equals 0, and 4 plus 3x squared isn't factorable, but it still equals 0. So this gives us some non-information or nonsense. And this, I'm going to take the 4 across the equal sign and make it negative, and then I'm going to divide by 3 on both sides. So x squared is equal to negative 4 over 3, and then I'm going to plus minus square root. And hopefully you remember that you can't square root a negative number, and we're graphing, so i's are garbage. So we end up in this particular case of having no points of inflection. And you're thinking to yourself, well, this is a great deal. That means I don't have a test. And yeah, that's not true, because you're in rational function land, and rational functions beat to the sound of their own drummer. I think that's what I'm trying to say. So, points of inflection. We've followed all the rules. Take the second derivative using the chain rule or the product rule or the quotient rule. Done. Let the second derivative equal 0. Done. Solve for x. Done. Can't sub x's back into y's because we didn't get anyone. So that was a useless clone on my part. There may be none. That's our case right here. So now, second derivative test. Boo. Draw a number line. Put on all the x values from the points of inflection. We're excited. We don't have them. Oh. And the vertical asymptotes. But here's the good news. Do not put on the max min points. Okay? They don't matter in second derivative tests. And then we can carry on. So I'm going to go back to the note. Version 1 of this note. And I'm going to draw my number line. That's not a number line. That's an asymptote. I'm going to draw my number line. Before I forget, I'm going to dig out my blue pen and tell you what it is that I'm doing. And then I'm going to double check what my vertical asymptotes. Remember, I do not have to go back to the vertical asymptote page. I can go back to the picture that I've drawn to find out what they are, or remind me what they are. So that's 2 and -2, which go on this number line. So -2 over here, 2 over here, and a reminder that I don't really care what's happening. These are just clues to drawing the picture. So I'm reminding myself that these are not points of inflection, they are asymptotes that are carving up the picture. So the fact that they're angled doesn't matter one bit. If I were not doing this on the smartboard, I would not have these functions and I would just make dashed lines through there. Second derivative, still need it. That was not a useless clone. So I only have 3 tests this time, which is kind of nice. Blue pen. I'm going to pick x equals -3. I'm going to pick x equals 0, and I'm going to pick x equals 3. And I'm going to put them into the second derivative because it's the second derivative test. So y double prime is equal to 2 is positive, multiplied by, if I take a -3 and I put it in here and I square it, it'll be positive, and then all this stuff is multiplying and adding, so I'm still positive. So I don't have to overthink stuff. However, if I put -3 in here, I get 9, and 4 minus 9 is negative, so I end up with a negative value, and that's concave down. Worth writing here. X equals 0 in the second derivative. 2 is 2. If I put 0 in here, I get 0 plus 4, which is positive. If I put 0 in here, it's 4 minus 0, which is positive. I don't actually care that this just alternated. I just have to make sure I follow that when I draw the picture. So that's concave up, and then back to 3. And you have to, in calculus, figure out where you can save yourself time. So, for instance, I know that's positive, that's a time saver, but I also know that whether I square 3 or whether I square -3, I end up with the same results. So I already know that this is going to be the same as this answer. And again, it alternates, but nobody cares as long as you match your picture. So let's see what the resource sheet says now that we've got all our clues. So I've taken care of my intercepts, and I've taken care of the asymptotes and their tests. I don't remember if I took care of the first derivative test and the max-mins. I know I didn't do this because I just finished it. But let's take a look at this thing. It's a sketch. Place and label all the points and asymptotes on the grid. Fit increase and decrease in lightly, and then make sure the concavity works. Or you can fit the concavity in lightly and make sure the increase-decrease works. I usually do this version, okay, unless I'm really stumped, and then I try this one. So let's see what that means as far as this picture goes. And remember, there is a second one coming. So I have to make sure that before my asymptote, I am going downhill. Then before the 0, which happens to be the y-intercept, I have to decrease. Then after I have to increase. Then I have to increase again after the asymptote. So let's see if that's even possible. So before the asymptote, I am supposed to decrease. And remember, this is light, so if you have to pretend that this is light, and the reason is because I have smartboard capabilities. So this does go downhill. Okay, so that works. It does go downhill. I need to go downhill till the 0, so I don't even have to put on new information. I have to go downhill until the 0, which should be my minimum. And then I have to go uphill until the asymptote. And I have to connect to all the little red arrows. And then apparently I am supposed to increase, so I'm supposed to go uphill after the asymptote. Uphill. So pretend that's light. Pretend that's super lightly drawn pencil. or pretend that's a first draft. Now we have to make sure that this works, because why would you do all this work for no reason? So I don't have any points to add, which is kind of nice. But I have to make sure that before the first asymptote, I am concave down. Between the asymptotes, I'm concave up. And after the asymptote, I am concave down again. Now, there's something to be said about concave down and asymptotes, and that is they could be split in half. So maybe it's just half of the concave down in either case, and the same thing here. Sometimes it's just half. So we have to see what's going on and make sure, like, we don't have to have bowl shapes all over the place. What we do have to do is we have to make sure that we're this way and this way and this way. So concave down, so frown, smile, frown. And I can tell that it's already worked. I've got half a frown here. That's the concave down. Here's the concave up. Here's the concave down. Everything matches for me. I'm good. So I have completely sketched this using all the tools that I'm supposed to do with calculus. So what I'm going to do is I'm going to stop this video, get myself some food, and then I'll make the second and last video of this unit. So we're going to go through everything, all these steps again. So I will clone this before so I don't have to write it down and waste my hand strength. All right, so that's it. See, I don't want to talk for an hour.